Hi class, in this last part of chapter 7 we're going to take a look at the main types of precipitation. The first one is drizzle. And so let's look at some of the characteristics of drizzle. First of all, I think by intuition everybody knows that drizzle means that it's a small drop size. And so how small is that drop size? Generally speaking, 0.2 of a millimeter to about 1/2 a millimeter. Oops, there we go. To 1/2 a millimeter is the typical drop size for drizzle. Now, why? Logical question next is, why is it such a small drop size? And we can trace that back to drizzle originates in stratus clouds. Okay, so why does that make a difference? Well, stratus clouds are low clouds, so their bases are closer to the ground. More importantly, though, these are thin clouds. Okay, and I'll draw you a picture here to show you why that's important. So stratus clouds are low and thin, so if we start off here at the surface and we draw the base of our cloud. So here's our LCL, just to remind us of terms that we should be keeping in mind. So a stratus cloud is going to be relatively thin. All right, and so we've got our low base, low cloud base, and the depth of this cloud is relatively thin. So maybe I'll use a little different color to bring this out. So we've got a thin cloud here to work with. Okay, and why is that important? Well, with a thin cloud, so we've talked about precipitation. Two ways in which precipitation forms is through the collision coalescence process and the Bergeron process. And so with a thin cloud, there is very limited opportunity for drops to grow. Okay, and there's limited opportunity for drops to grow because of the cloud is so thin. And so, if you've got droplets forming in here and it's falling through the cloud, as it falls through the cloud, it picks up droplets below it, and they coalesce together and they grow. So if you've got a thin cloud, there's very limited opportunity for those droplets to grow. And therefore, they're not going to grow to a very big size. They're going to remain small drizzle drops with, excuse me, with a diameter of 0.2 to 0.5 millimeters. Okay, and so other things we need to keep in mind then, as this drizzle drop then falls below the cloud base. Okay, so it's a smaller one. So keep in mind that the smaller the drop size, the greater the chance that drop evaporates, the greater the chance the drop evaporates. Okay, so if we're looking at droplet sizes of 0.2 of a millimeter, those are pretty small. Those have a greater opportunity for evaporation. And remember, if you're going to start evaporating droplets, small drizzle droplets, if they evaporate, that's going to lower the cloud base and maybe lower the cloud base some more, and lower and lower and lower, so that the possibility then with very small drizzle droplets is that this could result in a fog developing. And so this is most likely going to be a frontal fog. Okay. And if that fog develops, we can get poor visibility. Certainly wouldn't be anything like an advection fog, but still, these frontal fogs can lead to poor visibility. And so that's something you'd have to watch out for. Okay. Now that, again, the whole cause of this is because of the smaller drop size, which is very characteristic of drizzle. Okay. But the smaller drop size is because of the cloud that drizzle forms in. It's stratus, which is a low, thin cloud, limited opportunity to grow. And because they're so small, those smaller drizzle drops might evaporate and create fog and poor visibility. Okay, so that's the first type of precipitation, is drizzle, and next we'll take a look at rain.